What we need to do, but sometimes we don't see the entire picture. As we go through this, you'll see there's a lot that's involved as we start looking at building out new facilities or renovating existing facilities. And this is just a way to bring a lot of that information forward to give you a better idea of what's really involved in some of the things that you might not have thought about before. That may be very helpful as you move forward. So, Digital Video Group has designed, engineered, and integrated literally hundreds of professional broadcast video and audio systems. And these things range from as simple as hooking a camera to a monitor or setting up a simple little NLE system on a desktop to renovating or relocating entire TV stations and building out major production facilities. One of the things that we learn by doing this kind of stuff is that our engineers and integrators really learn firsthand the intricacies of many of the technologies that we work with. Because of this, every new project that we work on really brings and gains from the successes of the previous projects that we've done. And we also gain from the failures that we've had on the projects. As those of you know who have been in this industry a long time, there's really no good place to learn everything that you need to know about how this broadcast industry works. So all of us who have built facilities, who maintain facilities, all went to that same school of hard knocks. And we all know that once you go to the school of hard knocks, you never graduate. It's one of these ongoing things where you're always constantly learning. Working with a company like DVG helps you in the terms that you have all that institutional knowledge that we've gained from working on projects in the past. We know what works, we know what doesn't work, we know where there might be some advantageous reasons to go in one direction and some disadvantageous reasons to go in another. A lot of times these projects are working on the leading or kind of even on the bleeding edge of technologies. Numerous times the current project that we're working on and you're working on, you may be the first one who has used a certain product or a new technology. And if there's any manufacturers here in the room, please ignore the fact that a lot of times this stuff isn't necessarily completely finished by the time that it ships. So you may have serial number 1, you may have serial number 10, but it's still the first generation of software, and it's not been unheard of a manufacturer to ship alpha and beta software where you think it's release software. A lot of times that software doesn't necessarily stabilize until maybe the 3rd, 4th, 5th generation. And so there are some issues. What you were told at a trade show, what you learned on a brochure, what you got off on the website about all these great features, they may not necessarily work on that 1st, 2nd, 3rd, maybe not even 4th version. And working with a company like ourselves, we have the experience that when we hook these things up, we see what works and what doesn't work. And so you learn from the problems that the guy had before. And so these are some things to pay attention to. So the big thing that we've really learned in this business is that we don't know everything. And so we ask. We ask a lot of questions. According to our salespeople, we ask way too many questions. But by asking questions and then by listening to the answers is how we figure out the best way to get a facility designed. That's number 1, going to do exactly the job that you need it to do, hopefully exceed the job that you need to do on your daily basis, and also be cost effective. Because we all know that the budgets that we all wish we had are probably a half or a third of what we really need to accomplish what we need to do. So by going through some of these processes and really identifying what's important and what's not important for these projects, we can actually tailor a system that's going to meet the budgets, maybe even save a little bit of money and make the senior managers and the accountants very happy, but also allow you to do the job that you need to do the job today, and also maybe do jobs that you never have been able to do because you haven't had the capabilities or the facilities to make that happen. So when a client or even one of our salespeople approach us in engineering and say, what is it going to take? They want to talk about a new project. What's the first question they ask? Well, the first question they ask is, how much? What's it going to cost? And we say, that's a really hard thing to do because they say, we want a 3-camera studio. What does that mean? A 3-camera studio can cost $50,000. A 3-camera studio can cost $2.5 million. So there's a lot of things in between that are required in order to know what's involved. So we have kind of an informal questionnaire that we have internally that goes through an entire production facility and says these are the things that we have to understand. It's an informal list because if we try to do it formally, it would take forever. So just to give you an idea of what's involved in that, I'm going to go through this real quickly. There you go. Okay, got it? Got it. Thank you. Lunchtime. That's the presentation. I was wondering if that was going to go over. Thank you for some of you for laughing. Thank you. All right. But the first thing we really got to do is we got to define the scope. Literally, I showed you that because that's the kind of stuff we do in our head every day. When somebody, one of our customers approaches and says we want to design a project, that's the list that we go through. We don't necessarily go through each individual detail depending on the project, but it's that extensive. And one part of the list that we see, there's two sections to it. One is the physical part of your facility, the other is the technical part of the facility. And as we go through this, and I'm going to go through this real quickly, I'm going to show you the level of detail that's required to really look at when you're really planning out a facility, so that you have a real good idea of what you're getting into. If we went through a lot of this in great detail, we could be here for 2 days. So I'm going to go through this real quickly. And any questions that you have, we're here for the rest of the day. We have almost the entire engineering staff in the back of the room. Please feel free to grab any of us and ask any further questions. So, when we're approached about doing a project, the first thing we say is we want to define the scope of the project. What type of project is it? Is it a greenfield project? Most of you know what a greenfield project means. For those of you who don't, greenfield isn't. You're starting from scratch. You don't have an existing facility. You don't have existing hardware. So we're starting from ground zero. Let's build this up as if we had nothing. We can plan this going through the roof. We have a renovation. We're going to take our existing facility, we're going to change it around a little bit. We're going to put in new consoles, we're going to put in new equipment because the old equipment's 10 years old, but we're really not improving the workflow, we're just renovating the facility. That happens more often than not. The next type of project is a facility move. You have to get out of your existing space, you have to go to another space in the building, or you have to go to a new building. That is different from a technology update or upgrade. Many times that we do facility projects where you just physically have to move, but the technology is not going to change. You don't have more switcher power, you don't have better cameras, you don't have new graphics capability, you don't have a bigger router, you just have to move. Other cases, you can do a technology upgrade. You're going to go from SD to HD. You're going to go from HD to 4K. You're going to go from a single camera insert studio to a multi-camera live studio. That's a big technology upgrade. We have to approach those type of projects completely differently than we would just a move. And then sometimes you even get the big kahuna where you get to move and you get to do a technology upgrade. Those are great. Those also have issues that you have to deal with. So once we define what type of project you're going to have, we now get into what type of formats we're going to be working with. Is this going to be a 1080i project? Is it going to be a 1080p 3G project? In essence, today there's not that much of a difference. A year ago, there was. Today there's not that much of a difference because cameras, studio cameras now in the 3G world are just about the same price as they were as the 1080i cameras were. So we can now start thinking about 3G projects. But we have a lot of customers who are asking us about 4K and UHD projects and what's involved in migrating to that type of projects. And so we have a couple of questions that we need to ask ourselves on that. Mostly has to do with signal flow. Do you want to work with quad 3G? Do you want to work with 12G? For those of you who aren't familiar with 4K technology, a quad link 3G means you have 4 cables to get the 4K signal back through your system. 12G means you have a single cable. Well, we're at a stage of the technology development right now where some products are 12G capable, some are not. Some are going to be quad 3G, which means you have, again, 4 cables, and not 12G. Some will do both. In most cases, you're going to have to build a hybrid system. And we've been through this before in our industry. Those of you who have been around when we changed from standard def to high def, when we went from composite digital to component digital, we've been through all this before, and so we have to look at a lot of converters. We have to look at how products handle one thing or another. You have to look at upgrade paths. Quad 3G 4K has been around since 4K technology has been around. It's going to be phased out eventually, but it's not today. So if you buy equipment today that's quad 3G capable, how is that going to work in a plant 3 years from now? And how do you build out a plant to accommodate, because a quad 3G system requires 4 times the resources that a 12G system does. So that means if you have a production switcher that has 36 3G inputs and you want to do 4K on it, that means you now, instead of having 36 inputs, you have 9 inputs. Is that going to work for you? If you want to build out a routing switcher that works in a quad 3G 4K environment, well, if you buy a 128 by 128 router, which is more than big for most of our clients, that now becomes a 32 by 32 quad 3G router. So maybe you want to grow beyond that. So now we can't look at a 128 squared router. Now we have to look at a 288 squared router or a 512 squared router to get where you need to go. And so all this has impacts. Where that impact is building out the system and in cost. Going to a 4K system, just the infrastructure alone is significantly more expensive. Look at the cost of the cables and the connectors. Look at the cost of the patch panels. In a 4K environment, for example, the cost of the cabling is about 2.5 times the cost as it is in a standard 1080 environment. If you look at patch panels again are about a 2.5 times price differential between a 3G rated patch panel and a 12G rated patch panel. Where does that make a difference? Well, in terms of real numbers, we're doing a project right now that has a 128 by 128 routing switcher that needs to be wired for 12G. The cost differential between doing the patch panels in 3G and in 12G was $24,000 just in the patch panels. So those are things you have to pay attention to. And then there's other issues like we talked about, multi-formatting issues. We haven't even talked about IP, 2110, 2020, NDI, etc. All the issues you have to worry about, metadata and compression, and a little thing called an SDN, which we're calling a social disease. But it was really known as a software-defined network. Those of you who've played around with some of the newer technologies might have heard this term before, but this is a term that you're going to become real familiar with in a hurry as we move into the IP world. As we move into the IP world, we're not going to have dedicated routers. They want to talk about COTS network switches, which is common off-the-shelf technology. So we can use network switches to do our routing rather than doing traditional dedicated routers. Well, to manage the signal flows in and out of these network switches, we need to have a software-defined network management system. You all thought that you were paying a lot of money now for software licenses and renewable fees. Just wait. It's going to get a lot worse. As everything moves to software, you're not going to be paying for the cost in the hardware, you're going to be paying the cost in software licenses year after year after year. And these are things to pay attention to as we move down the road. So moving forward to accelerate this, we start getting into studio issues. And so we start looking, when we start planning out a facility, look at the size of the studio. How big is it? Where's the ceiling height? Are we going into an existing facility that has a drop ceiling? Are we taking that drop ceiling out? Are we going up to the slab? How far is it from slab to slab, from the ground to the ceiling? What's up on the ceiling? Do we have pipes? Do we have electrical grids? Do we have air conditioning systems that are up there? You have to look at the floor. How is the floor being done? Most construction companies don't build floors to what we need to in a studio. They're not necessarily flat. They're not necessarily level. And if you're going into the floor, do you just do a concrete floor and put down floor tiles? Do you epoxy the floor? That's a lot of fun. Or do you actually have a construction company build an isolated floor that's isolated from the building so that building noise doesn't come into the room itself? We have to look at the lighting grid. Where is the lighting grid going to be placed in relative to the ceiling? If it's a drop ceiling, where is the slab? How far down? If you have say you have a 20-foot ceiling, where do you put the lighting grid? You put the lighting grid right next to the slab, or did you drop it down to 14 feet? Who's going to do the lighting system? Who's going to put in the electrical for the lighting system? Who's going to step back and do the DMX setup for the lighting system? Little things that need to be taken into consideration. Then we have our good old high-tech sight curtains that go around the studio. Do you want the sight curtains to go all around the studio, or do you want it to go partially around the studio? How many curtain tracks do you need? 1, 2, 3. What colors are they? All the fun stuff. How high do you need those sight curtains to be, and where are you going to hang it? You're going to hang it off the wall, you're going to hang it off the grid. All these little things come into the factors. We move now into sound reinforcement. Sound is a real big issue in the studios that we don't really pay attention to until kind of the rubber hits the road. So it's the sound reinforcement, not only inside the studio, what are the acoustics inside the studio, but it's also how the studio relates to the environment around itself, the hallways outside the studio, the offices that are outside the studio, the parking garage that's underneath the studio. Here in Washington, we have subways. And there have been enough facilities where when the subway goes under, you hear it under the control room or inside of the studio. We have to worry about sound going outside of the control rooms and the studios into the neighboring places within inside your building. In a lot of our facilities, we're in office buildings. So you have to worry about sound transmitting through the walls, through the doorways, up over the ceiling into your corresponding areas. So we have to worry about sound, and we have to take into consideration sound isolation, walls, doorways, and ceilings. All these things have to be taken into consideration. We have to deal with noise levels. There's something called an NC rating, which is called noise criterion. For those of you who aren't familiar with it, there's a whole bunch of different levels, and there's kind of a correlation to dB levels. We won't get into the math because I don't understand it. But anyway, in the studio environment, recording studios, you'll do anything from an NC15, which is very, very quiet, and also very expensive to build an NC15 studio, out to NC25, which is pretty good for most broadcast operations. This is real critical if you're building out a new studio and you're working with a construction company, because the chances are they have never done a broadcast studio before. And so they're building this like they would build a conference room. And they will see a spec that says NC15, and then you will see a bill that will just make your hair fall out because it is really expensive to build an NC15 studio. Just the doors themselves can be in the tens of thousands of dollars to build a really good sound reinforcement door, especially if you put 2 in with an air chamber. You can see the other specs on here. NC35 is pretty standard for a conference room. With the AC that's running in here and the acoustics, we're probably like an NC50 or 55 in here to give you a perspective. So again, as we talked about, we have hallway noise, ceiling noise, air conditioning noise. You have to look at the air conditioning. Most buildings, like 102% of them, are not designed for air conditioning to be quiet in the studio. So you have to look at doing the air conditioning differently, the way that you narrow your ducts down as you go further and further in the studio, or you make L bands going around in order to keep the noise down. Plumbing noise. Many times we go into a facility and there are pipes running across the top of the studio or the control rooms. And every time there's a flush, you know what that guy had for lunch. It's a lot of fun. So these are things to pay attention to. Going further on down, we got to put connection panels inside the studio. So we have something called broadcast service panels. So now you have to look, how do you get the cables from the tech core in the control room out to the studio and back? So you have to look at pathways. Do you have conduits? Do you have cable trays? Is it going through a raised floor? If you're going up over a drop ceiling, what's up there in that drop ceiling? Do you have AC ducts? Do we need to have plenum? So there's an issue that's called, for those of you who haven't been involved in, plenum is a fire-rated cable. Fire-rated cable is 4 times the price of non-fire rated cable. So instead of paying $900 for a 4,000-foot reel of cable, you're now paying $3,600 for that same roll of cable. And when you're doing a big system that requires 30 or 40,000 foot of cable, that adds up in a real hurry. All these things, and of course, every time that you talk to facilities people, say, is it a plenum airspace? They say, no, it's definitely not a plenum airspace, which means that it probably is. And when the fire marshal sees you have non-plenum cable in the plenum space, it gets real nasty. You have to worry about places where you're going to put sets, where you're going to store things. All these things you have to take into consideration when planning out the system. When we move into the control room, whoops, hold on a second. Going too far. There we go. So we talk about the video control room. We need to look at the location of the control room relative to the studio and the tech core. We want to look at the size of the control rooms. Many times we get drawings from architects and consultants. The control room is tiny. They don't take into consideration line of sight from the TD's eyeball to the multi-viewer screens or the production monitors. That needs to be a certain distance in order to be effective. We're doing a project right now where the eyeball distance from the multi-viewer screen to the TD is about 2.5 feet. So we're putting in wide-angle contact lenses in order to make sure that they can see this thing properly. The layout of the room, where do the consoles go? We spend a lot of time rearranging and catting out where console layouts in order to maximize and optimize the layouts for operators so that, again, you can see line of sight so that people can walk behind each other. You need at least 3 foot of space. If you're doing 2 rows of consoles, you need between 3 and 4 foot of space between one console and another, because bodies and chairs are so wide and so deep, and then you need space to get in between and move around. A lot of times that's not taken into consideration. Do you want a window in the studio? There are people who still like to have windows in the between the studio and the control room. Where is that placed? How is that going to impact how we lay out the consoles? Many times that window is right where we need to put the console, and so for the studio you can see the back of your console and all the cables and the monitors. It's a real good investment to make that happen. Audio control. Is it going to be in the video control room? Is there going to be a separate room for that? How do you get information from one to the other? Then we move to the tech core. Okay, is it tech core? Is it going to have a separate room, or are they just planning on putting the racks inside the control room? Well, if the control room is 8 by 10 and you got to put 2 racks in there plus an operating console, it gets awful crowded, it gets awful hot, and it's awful loud. And we've gone back and forth in many facilities where they want us to move the racks after the fact, a year or two after the fact, out of the control room into its own dedicated room. That's a major project, especially if you don't take that into consideration right up front, because the cables that you installed 2 years previously aren't long enough to accommodate moving to a different room. So basically you have to rip it out and start from scratch. So if you know that you have to put everything into one room and then you might have to move it down the road, that should be taken into consideration. So it's kind of like the insurance game. You either pay us now or you pay us later. So to prepare up front, that can be helpful. Where are the edit rooms going to be located? You're going to have a sound booth. Is the sound booth going to be in the studio? Is it going to be in a control room? Is it going to be in another part of the building? And then you have to worry about cabling and ventilation into a sound room. And those are things that you don't think about until the very end. We have to worry about things like HVAC. If you're in a corporate office building, do they turn off the HVAC at 5 o'clock at night and over the weekends? Many a time we get phone calls Monday morning saying, we just walked into the tech core and it's 107 degrees with 75% humidity. Are we going to experience any problems? Maybe. Do you have 24-hour access to that? Normally we recommend having independent HVAC. So does that mean we have to put different HVAC units inside the tech core and the control room that are independent of what's in the facility? Power, big issue. Do we have independent power circuits for the racks, for the control areas, etc.? Do you have UPS, building UPSs, surge protectors? Do we need to take that into accommodation? Cable conduits between the rooms. How do you get cables from one room to the next? Well, a couple different ways. You have raised floors, you have cable trays, you have conduits, and then of course our good friend plenum all comes back into the issues. These things need to be paid attention to. So this is just all the logistics and the physical stuff that need to be addressed when you're looking at a brand new facility before we even start looking at the hardware. So let's actually start looking at the hardware. And we're going to go through this real quickly. And again, ask us at any time, either today or any time later, and we can go through this in real detail with you guys. So we start with cameras. You get studio configuration. You're going to do SMPTE fiber, you're going to do single mode fiber, you're going to do triax, or you're going to do single link video cables. If a lot of people like the idea of using E&G style 4K cameras because they're cheap. You can get a really nice looking camera for $3,000 or $4,000 and stick it inside the studio and say, hey, why spend $40,000 for a studio camera when I can use an E&G style and it's going to give me a much better picture? Well, yeah, but we have some other issues you have to take into consideration, such as lens control. Most of those little cameras only have lens control in the front. In the studio, you want to have lens control in the back. It's separate focus, separate zoom. A lot of those cameras don't have that capabilities, or if they do, they're kludgy. You have depth of field issues because of the larger sensor. Connectivity issues. With an E&G camera, that means you now, instead of running a single cable from the camera back to the tech core, you're now running video, genlock, ping control, prompter, return feed, intercom, and power as separate cables. More points of failure, more points of something going wrong, and just a real mess going across the floor. Depending on your environment, that can be a real big issue. With the cameras, you got to worry about pedestals or tripods. How much floor space do you have? Are you going to be running manual control cameras or PTZ cameras? If you're running PTZ, are they going to be all-in-ones, like the dome cameras and the conference room cameras, or are you going to have a separate head, lens, and camera? Then you have to worry about controllers. There's going to be a hardware controller, software controller. Could it be both? How are you going to control that? It's serial or IP? If you do it serial, it's a little bit cheaper, but that means you have to daisy chain from one camera to the next, to the next, to the next, and you have a boardroom that's 100 feet by 70 feet. That's a lot of cable that needs to be daisy chained from one to the other, and you have points of failure issues. So if you do IP, now you have to make sure you have the right modules inside the cameras in order to talk properly going back. Little things to pay attention to. Does the PTZ system need to integrate with a production switcher? Does it need to interface with an automation system? Things to take into consideration when you're making those decisions. We move into the production control room. And now we start with the production switcher. So questions you want to ask yourself. How many inputs? How many outputs? How many mix effects buses? Do you need a single bus? Do you need 2 buses? Do you need 3 buses? How many aux buses? Do you need those aux buses to do transitions? How big does the control panel need to be? Do you need 10 cross points, 16 cross points, 24 cross points? Is it a big production? Do you need 33 cross points going across? And if you do you have the space on the console to accommodate that? If you're going into a production truck, you may not have a lot of space to put a console, so you have to make a compromise on what kind of production switcher console you have because of the space that you have allocated to work with it. Do you want a standalone production switcher, or do you want to have an all-in-one production switcher where the graphics, the servers, the audio mixing is all built into the unit itself? And there's pluses and minuses that go with that have to be taken into consideration when we do the engineering design. And then do you need to have an interface to third-party devices like PTZ cameras, like routing switchers, like external character generators, things of that nature. Nowadays, almost all production switchers have multi-viewers built into it. Great. Okay, so do you want the multi-viewers? How many do you need? 1, 2, 4, 6, 8, depending on your facility? Makes it depending. How much support of ancillary data do you need to have in those multi-viewers? Do you need to have audio meters on those multi-viewers? Do you need to be able to see tally information? Do you need to see time code? Do you need to have closed caption decode? Do you need to see AFD information on that? That's a big decision process. Does a production switcher, if it's 3G support, do you need it to do 4K at some point down the road? So 5 years from now, you can take your investment and move it to 4K. Well, if you do, are we going to do quad 3G, 12G, or IP? Some facilities might want to have multiple control points. If you're doing a stadium project, you might want to have a live event broadcast and also do a production that goes to the boards inside of the arena. So do you need to have multiple control points? Houses of worship are exactly the same thing. You might want to have one switch feed that goes to the iMac, to the projectors inside of the chapel, and you might want to have another feed that goes out to your live stream or to your record that's going to go out for broadcast. When you move into audio, as I said, we're going to go through this real fast here. Audio, you want to have just a local audio mixer like we've all been used to, the little Yamahas or Mackeys where everything plugs into the mixer? Or do you want to have a mixer that is frame-based? So like a production switcher, the audio mixing frame is back in the core, and you have a console that's sitting out in the control room. It makes the engineering of the system much more effective if we don't have to run a whole bunch of analog copper cables out into the control area when the tech core is 150 feet away from that control area. If all we have to do is run one Cat5 cable from the mixer console back to the frame for control, your cost goes down significantly to make that happen. So now we have to, with the audio, again, same thing as the switcher, inputs and outputs. Do we want local I/O to the mixing console, or do we want remote I/O? What type of inputs and outputs do you need? Do you need analog? Do you need AES? Do we need MADI? Do we need Dante? Remember how they said going to digital makes life a lot easier? Back in the day, all we had to worry about was the 27 different videotape formats. Piece of cake compared to today. There's so many different variations of technology to take into consideration, and all of them have their advantages and disadvantages, and that's all factored into the viability of the project as we move forward with a lot of these questions. How many internal processing channels? The number of inputs and outputs you have on the system does not necessarily mean it can accommodate those inputs and outputs, or it may accommodate a lot more of them. In the digital audio world, where we have multi-channel MADI and Dante signals coming into the mixer, you have one cable, but that one cable can handle 64 different streams, or 128 different streams, or 512 different streams. And so you need to make sure your mixer can accommodate all of those streams that are coming on off that one single connection. Do you want to have internal auto mixing? Internal auto mixing is a new function. You might have heard it called Dugan auto mixing, that basically allows you to say this number of microphones are going to have this kind of medium level, and the mixer automatically rides levels for you, and the technology works really, really well. Once you work on it, you never want to touch a fader again. It's really great technology. But again, the mixers that have that, it's a certain level of mixer. How are you going to do your monitoring in the control room? If audio is in the same control room as video, monitoring is handled one way. If audio is in a different room, audio is handled another way as you plan it out. And then, of course, we have our ancillary audio devices such as CD players, media players, DDRs, telephone hybrids, etc., that we need to take into consideration. Move over to graphics. How many channels do we need? Do we need to interface to external data sources like RSS feeds, or if we're doing scoreboard systems or something of that nature? Are we interfacing to other devices? Does the CG need to be controlled by if you're doing a high-end broadcast automation system, does it need to interface to the production switcher? Because you have one operator who's going to show up for this production, and that operator has to be the TD and the CG person. So do you want all the control consolidated to one particular point? Do you need to have a custom UI set up if you're doing special events like sports events where the standard CG interface is just cumbersome? You need something specific for sports or specific for a live event. Are you doing a newsroom operation? And this isn't just for broadcast stations. A lot of PEG channels are now looking at doing newsroom systems and doing local news. And so do you need to have the newsroom system interface into graphics? Video servers. Likewise, number of channels. How much storage do you need? Do you need the storage to be scalable, or can it be fixed? If you know that you're going to have 4 terabytes, 8 terabytes, 12 terabytes, and that's all you ever need, that's fine. Do you need a RAID level? RAID level 1, RAID level 5, RAID level 6. Again, depending on what your needs are, is going to drive the selection. Do you want to have local drives on side of this server, or are you going to have network drives or external drives? If you have local drives, what do you want? You want spinning disks or you want SSDs? Spinning disk, you can get a lot more storage, it's a lot cheaper. SSDs, less storage, more expensive, but faster. Little things that you need to pay attention to. With the video servers, if you want external drives to that video servers, how are you going to do it? You're going to do it with a NAS. You're going to do it with a SAN. We're going to do a network drive, or our favorite thing, the cloud. And again, there's all kind of issues that are involved in making these decisions. Do we need to interface this to NLE systems? If we do, now we have file format support. We have import and export issues. So now we get into our little friend, the codecs, and how that all interacts together between NLE systems and the servers, and also our streaming encoder devices. As we're recording, we now have dedicated recorders that we plan. So whether they're XD cam decks, whether they're SSD devices, whether we're doing something to a flash drive, or maybe something like a Key Pro or HyperDeck or something of that nature, decisions are, do we need fixed media? Do you want removable media? Do you want the recorder to be timecode based like an old videotape machine does, or do you want it to be file based? What kind of compression ratios do you want to work with? Is it highly compressed? Is it low compressed? Depending on what type of work you're doing in the studio, you might want to have a lower compression ratio, so when you take your media recorded in the studio and bring it to post-production, you can do things like chroma key properly, which is something that's overlooked many times, where somebody records something on a lower resolution recorder, takes it into post and says, our chroma keys don't look very good. Well, yeah, that's because you encoded it at 10 megabits per second instead of 100 or 200 megabits per second. Little things like that that can be very expensive if you don't think about it beforehand. Storage amounts. How many hours do you need? If you're doing a live boardroom show, your live city council meeting or school board meeting may last 3 hours, it may last 10 hours. So you need to make sure that your recording device can handle that span of productions. We get into recorders. With the recorders, we get control. Do you need local control in front of the machine? Do you need remote control? If you need remote control, is it from a production switcher or is it through a web interface? So we have serial versus IP. And then how are you going to monitor it? You need to monitor it locally. We're going to monitor it with dedicated monitors. We're going to run that through the multi-viewers. And then, of course, audio. Same issues. Are we going to do analog, AES, embedded, where the audio is on the HDSDI stream, and our friends Maddie and Dante. For monitoring, we do this on every single project, okay? And our salesmen ask us why it takes so long to come back with responses. So, I mean, these are things, a lot of times we can take, at a glance, we can understand what the answers are to a lot of these questions, but this is what we go through on every single project, and we really stress that our customers do exactly the same thing, so that there's no surprises. For monitoring, you have studio monitoring. So you have on-set monitors, you have talent monitors. In the control room, we have TD program monitors, and you have your multi-viewer monitors. On your tech core, you want to have probably a quality control system for monitoring, and also you have shading. If you're lucky enough to have engineers if you're lucky enough to have engineers. Number two, if you're lucky enough to have engineers who know how to shade cameras properly, you have a shading station that needs to have monitoring. Green rooms, we need to get monitors back to the green rooms. And if you have an audience in your studio, and we see this a lot more now in educational environments where the classroom and the studio are one and the same. So we need to set up monitoring for the studio itself. You run into IMAG scenarios where you need to have live video inside of the room that people are looking at, and now you have things like delay that have to be taken into consideration, because the image processors in an AV world, they don't care about real time. So you may have a 5 or 6 or 10 or 15 or 20 frame delay from what's happening up on the podium to what's happening on the IMAG screens. And some people just can't deal with that. They want to see things that are maybe a frame or two off at the most. So that needs to be taken into consideration. Audio needs to be taken into consideration as far as the studio. So you have foldback issues back into the studio. In the control room, we have control room speakers, audio cue speakers, individual operator speakers. If you're into replay, the replay guy needs to be able to hear what he's replaying. And if that guy is sitting next to your TD, you want to make sure that what he's doing on replay is not going to overwhelm what the TD's hearing on the program mix. In the tech core, again, quality control station. We need to hear exactly what's going through, and how do you do that? Do you have outboard embedders? Do you have speakers that have embedders built into them if you're working in a fully embedded plant? Green room needs to be able to hear things. Do you have separate speakers in the green room, or do you hear it through the speakers in the TV set? If you have to have separate speakers, there's costs involved in getting, and how do you get that cable over to the speaker, and where do you put the speaker inside of that room? Our friend, the intercom systems. We have choices between party line systems. In a party line, do you have analog or digital party line? They all have their own unique challenges. Do you go with the matrix switch? Pretty cool, but expensive and a lot more complicated. Or you want to have intercom over IP. That's coming, it's here, and there's hybrids out there. And interfacing into IP-based systems is pretty cool, but it's also very expensive. And there's a lot of gateways. That's another neat term that we all are going to be hearing a lot more these days. It's called gateways, which are going to be bridge products between one level of technology and another. And we're not going to get away from that. We're going to see that a lot more. Do you need the intercom to be wireless? How many control panels do you need? What size control panels? How do you want it to work? Do you want to have flip switches or rotary knobs? Headsets. How many headsets are you going to need? Single muff, dual muff. And we get into things like IFB, number of channels, receiver stations, wired, etc. We can go on and on. You can see all this other stuff. We get into routing switchers, all the little things with routing switchers that we have to deal with. Same things that we talked about with other type of product. We have reference generators, all the different test signals that we have to deal with, etc. I'm going through this real fast because there's a point here that we want to get to, KVM switches, etc. Closed captioning, another big issue that we have to that need to be taken into consideration. And are you going to be doing local captioning, or are you going to be doing remote captioning services, and how that all works together? And then, of course, furniture, racks, etc. We haven't even touched master control and post-production, and that's a whole other issue. So we could be here a long time talking about all these things. You have professional services, getting into design work, doing scope of work, equipment designs, bill of materials, etc. Getting into the engineering and what's all involved in doing engineering drawings and setting up schedules, order processing, off-site integration, on-site integration, commissioning, working as integrator only or working manufacturer commissioning. Testing out the system, doing training, same thing. Do you have the integrator do the training? Do you do your own training? Do you bring in the manufacturer for training? And then we have the warranty issues, and that's another whole ball of wax to take into consideration and what that means. So after you have all these equipment issues are considered, you really need to sit back and worry about the logistics of how you're going to actually make this work, how you're going to make the purchase. So we can't stress this enough. The technical and engineering resources need to be involved in the projects right up front. Many times in these projects, it's the facilities people who are looking at the space, and they have made 90% of your decisions for you in terms of floor space and budgets before you even can say, excuse me. And we see this time and time again. Really, really important for new construction projects. As we said, many times these decisions are made by people who have no idea how to do production or what's involved, and they don't care. And the first time that you, the person who actually has to do the production, actually sees what you have to go work with after your company has spent $1 million building a new facility, is when the integrator says, okay, ready for training. And you've had very little input. So we stress, try to get involved as early as possible. Because if you don't, it's going to be too late to make any changes, and you're going to have to live with what you have. So the point is, get involved as fast as you possibly can. Also, it's generally wise to have the system designer also be responsible for integrating and testing the system. Now, this is a very self-serving statement because that's what we do. But why is that the case? Because when you follow a design build philosophy, it ensures that the designer's ideas and thought processes are followed through with the final as-builts. So let's look at this. In a typical building scenario, you have a consultant. Consultant comes in, says, okay, what do you have? How much money do you have to spend? They create a conceptual design that's generally based on designs that they have done before. It may or may not include some detailed system drawings. Generally, it's kind of somewhere in between. Then they generate an equipment list. A scope of work document's created. Sometimes that scope of work document has a detailed description of the workflow. Many times it does not. It just has a basic description of what the hardware is. Once the design phase is complete, the next phase is you put it out to bid. When you put it out to bid, it could be a significant time between when it was designed and when it's going out to bid. So the technology that's in the design may be obsolete. There may be new stuff out there. Some of the stuff may not exist anymore. And sometimes the equipment procurement is done separately from the integration procurement. And sometimes the equipment is awarded to a single vendor, and many times it's awarded to multiple vendors. So when the integration phase is bid out, and the perfect storm scenario you have, a designer, an integrator, and multiple equipment suppliers. So multiple companies are involved in building the facility that you need to operate. Needless to say, the possibility of chaos exponentially increases as more players are involved in the process. And believe me, we've lived through this, and I'm sure many of you have lived through this also. The system integrator takes on the role as a project manager. The project manager's job is basically to integrate the shop drawings with the consulting engineer's design. Okay, that's a lot of fun because you have two different companies with two different purposes, and generally the consulting designer is moved on to the next project, and he's no longer thinking about this one that he designed a year and a half ago. The project manager needs to then interface with all the equipment vendors to make sure all the equipment comes in properly. The project manager also needs to verify that all this equipment that came in actually works out of the box. How many times does that happen? There's always a DOA somewhere along the line. Something gets damaged in shipment. If something's missing or damaged, well, the project manager just can't go back to the vendor and say, hey, you need to replace this. They have to go back through the equipment supplier, who then has to go back to the manufacturer to get things done. The clock is ticking, and these things don't necessarily get resolved very quickly. Once the equipment issues are settled, integration phase proceeds. We put up the racks, cables are cut, terminated, and connected. Equipment is turned on, set up, and commissioned, and finally, everything's commissioned and it works together. This is where the theoretical hits the reality. Okay, this is the fun part, because sometimes that connector that was shown in the manual or the product literature is really different or doesn't exist on the product. How many times has that happened? That crucial option that ties the server and the automation system together, which interfaces to the traffic system. Oh, that's not going to be in this version. That's going to be in the version in the spring. But that's what you needed to have happen. But you know what? It looked really, really good at the trade show, or that article that you read, or the demo that you got from the manufacturer really seemed to play that up, and that's what you were basing your system on. And sometimes that interface that looked really, really good at the trade show was just a beta intersite that was going to a little dummy demo system and really is not designed to work with the physical hardware that's out there. You are the beta site. You're going to make this happen. So that it's time proven that that what is supposed to work a certain way doesn't always work that way. How do you know that? Through experience. When you go into these projects with a little bit of cynicism, a lot of optimism, but a little bit of cynicism, knowing that if you can get screwed, you probably will be, but you need to be prepared for it, and you need to know how to react when and if something like that happens. Those people who build systems often learn the hard and costly way, and the man sitting in the back of the room with the blue tie knows exactly how much that can cost sometimes when we make those kind of mistakes. So we try not to make them, and we use the experience that we have building other systems to minimize that to happen when we don't want that to happen to you guys as we build projects. Because just because something that says it's going to work or the factory rep says it is, doesn't mean it's going to happen. So if the engineering designer is not contractually responsible for the integration, who takes responsibility when these issues arise? A project is more efficient if the engineering designers and integrators work together on the same team. That's really, really critical in terms of making sure the project works. It works the way you want to. It works, it's finished on time and finished on budget. Because otherwise, when, and generally it is a when and not an if, there is a discrepancy between the design and the integration. This is where I spent all the time on this presentation, so please pay attention. It's the old finger pointing game. Now, unfortunately, let's see if this actually works. Hey, it actually worked. It's that game. Who's responsible? The guy who designed it or the guy who builds it? A lot of times in our contracts it says, this is a conceptual design and the integrator is responsible for making it work and you can't charge any more. So who's the big loser in this game? It's you. You're the end user. Don't let that happen. Try to prepare, look at all of these things up front. Hopefully this gives you a little bit of a primer on things to pay attention to and all the detail that can be involved. There's a lot of work involved. It's worth it in the end run. And that's why companies like Digital Video Group exist, in order to make your life a little bit easier. And oh, by the way, did I mention we're a system integrator company, so this is a little self-serving. And now the most important slide of the day, and 8 seconds over, it's time for lunch. Thank you.